So what we have here is we're going to introduce another component, which is a relay. This is a single coil relay. Again, it operates as a switching device, but it's electronically operated. And you're kind of using, you're switching the switch if you like. So a rocker switch here. If I press this button, close the rocker switch, I send a current through the coil of the relay, which switches the contacts here and turns on the LED. So this is our circuit diagram. This here represents the relay. That's our rocker switch, a resistor and LED. Now, the way we normally represent a battery or power source on a circuit diagram is we show 9 volts in, that's plus, and then we show ground here. That'll be the negative side of the battery. So what a relay does is it switches these contacts. Okay, so you have common, normally closed, normally open. As you can see at the moment, the relay is connected through normally closed. So that's normally closed. But the LED is connected through normally open. So at the moment, there is no current going down through the LED. So the LED isn't illuminated. When you close this switch here, it puts 9 volts through the relay. And what the relay does is it switches the common from here to here. So now you have a connection here and you have a current going down through that. When you turn off the switch again, there's no current through the relay and it switches back. So you're using this current through this coil, bit of an error there, current through this coil to switch the contacts here. Okay, so we'll look at our little setup again. Now, why do we use circuit diagrams? Because if you use a circuit diagram, it means everyone knows what you're doing. Whereas if you just showed a picture of this with all these wires everywhere, it would be hard to discern what's going on. But again, let's look at it in a bit more detail. So we have our battery here, which is our power source. That's our plus side. That's our negative side, ground. So positive goes through here and to ground. And that is controlled by this. Because in order to get to ground, you have to switch this. In order for that coil to get to ground, you have to switch this. So if we switch that, we get a current through here and it'll switch the contacts there. I'm using a 9 volt battery. This relay is actually a 5 volt relay. It'll operate on 5 volts, but its maximum voltage is 10 volts. And this battery, they lose power over time, so it's probably only about 7.5 volts. So that's safe enough. Now, if I take the relay out of the board, you can see that we've several pins on that. So these 2 pins here, show it like that. These 2 pins here are for the coil of the relay. And these pins here are your common, normally closed, normally open. And what you can see is that we've 2 circuits effectively on the relay that have a common, normally closed, normally open. So I can operate 2 different circuits here. I could be switching on and off the LED, and I could be turning on or off a motor with these ones. And we'll be looking at a bit more detail on that later on. So that's how relays work. That's what we call a single coil relay, basically. Over and out.